Hello, welcome. Today we're going to be looking at process dynamics, optimization, and control. We need to know what a process is, then we know what process dynamics is, what process optimization is, and what process control is. A process is a set of resources or operations that transform a substance chemically or physically into another substance or mixture of substances. So let's say a process that transforms crude oil to kerosene, PMS, and other forms of fuel. So that is a process. In the refinery, we have such processes. We can call it a refining process that refines crude oil to the various components to be used as fuels for car and for fuels in the house for our cooking. So that is a process. Any set of operations that transforms the crude oil or any substance or mixture of substances to another substance or mixture of substances. In this case, transforming crude oil to the various components like PMS, kerosene, and others. So that is what a process is. It can also be a process that can transform palm kernel oil to soap. You understand? That's the sort of a scenario. We call it soap production process. So anything that you use in producing something or using changing something to another thing, call it a process. Now, process dynamics. Process dynamics simply means that such processes, they are not steady state. There are things, the factors of production or the factors that are involved in such processes change from time to time. So because they are changing, we call it process dynamics. It's not constant. If you say you want to produce 20 soaps in a day from your palm oil or something, there might be reduction in your supply of palm oil or something might happen in the factory. Many things will change. So these changes are known as dynamics. They are transient, they are not something you can say it will happen or it will not happen. But for you to be able to check these changes and make sure that it doesn't affect your production, you bring in what we call control. So control is simply automatically making sure that all these changes that you don't plan for that will normally happen are gotten back to the set point, stabilizing the operations, stabilizing the processes, so that you still have what you had initially wanted to have. So we call it control. So you control a process because there is what we call process dynamics. There are changes in the process. So you control it to make it still what you want. So we call it control. And how do you go about controlling? By installing sensors, so that once they dictate such disturbance or changes, they can still change back the variables to the set points. These variables, set points, and sensors are what we'll be treating when we go deeper into control. Now, lastly, optimization. Optimization simply means determining the maximum or minimum of an objective function. You know that the maximum or minimum is normally the optimal condition for operation. Let's say you're producing soap, you want to make maximum profit. So you need to determine the condition that will enable you to make maximum profit. You want to use minimum cost. You need to determine the variables or conditions that will enable you to use the minimum cost. So in this case, the objective function is the cost or the profit. So you must make sure that within the constraints that you have of lesser labor, maybe lack of electricity or lesser electricity, that you maximize your profit or minimize your cost. So optimization is when you try to determine the maximum or minimum of these objective functions that can be cost or profit or quality under restricted conditions known as constraints, things that will not allow you to make those such maximums like labor or other things. So you see that process is anything that transforms one thing to the other. This transformation is done under changing environments called process dynamics. And to control this changing environment, you need what we call process control, to put it in order. Then once you have your control, you need to maximize your profit or minimize your cost. And to do that, you need what we call process optimization. So that is this course, process dynamics, optimization and control. A process is a set of resources or operations which transforms physically or chemically a substance or mixture of substances into another. A process is a dynamical system whose behavior changes over time. These changes are on steady state and transient. And these process behaviors are described by different equations. Control, process control, takes care of the disturbances caused by the dynamics of the process, stabilizing the system to set value automatically to ensure steady continuous process of production. Optimization involves the determination of the optimal, which can be maximum or minimum value of a given function, called objective function, subject to set of restrictions called constraints. Example of this objective function, or example of things that we try to optimize are profit, quality, or cost. An example of the restrictions that we have to consider when trying to make these optimizations are labor supply, resources, and other factors of production. So in subsequent classes, we are going to be deeping the intro, process control, and optimization, considering what we call process dynamics. So we're going to take process control first, then later we'll take optimization. Please, if you like this our video, click on the subscribe button, like, share our video. Thank you, and see you in the next class.